Welcome to The Explainer. Today, we are diving deep into the core philosophy of React. If you've ever felt like you're fighting with React instead of working with it, you're definitely not alone. We're going to break down the mental model that, once it clicks, makes everything just fall into place. So let's get into it and really start thinking in React.
All right, so here's the game plan. We're going to start with the big idea behind React. Then we'll look at its fundamental building blocks. After that, we'll see how they come alive with something called state, learn how to organize that state so you don't pull your hair out, and finally, we'll touch on how React talks to the outside world.
Okay, first up, the single most important idea you need to get your head around with React. It's the shift to a declarative mindset. And trust me, it fundamentally changes how you think about building user interfaces.
Just think about a complex form. The old way, you have to write code to manually handle every single update. Okay, enable this button, now show that success message. Oh wait, disable this other input. It becomes this tangled web of commands that gets incredibly complex, and it's a huge source of bugs as your app gets bigger.
And this brings us right to the core difference. Imperative programming is kind of like giving a driver turn-by-turn directions without ever telling them where they're ultimately going. You're micromanaging every single step. Declarative programming, which is React's whole approach, is just giving them the destination address and letting them figure out the best route. You describe the end result, not the steps to get there.
So what this means in practice is you stop commanding the UI to change. Instead, you just describe how it should look for any possible state. Is it loading? Did it succeed? Is it empty? React then acts like that smart driver, figuring out the most efficient updates to make your description a reality.
So if we're describing our UI, what are we using to write those descriptions? Well, the answer is these small reusable pieces called components. You can literally think of them as individual Lego bricks you use to build your entire user interface.
Now, to really get components, you have to understand pure functions. Think of a simple math formula like y equals 2x. If x is 3, y is always 6. It doesn't matter what time it is or what the weather is doing, the output is predictable and depends only on the input. It just minds its own business.
And here's the magic. React is built on this really powerful assumption that every component you write is a pure function. This means that given the same inputs, or props as we call them, a component will always render the exact same UI. This is what makes React applications so predictable and way easier to debug.
But let's be real, a UI that never changes isn't very useful, is it? So how do these pure, predictable components handle user interaction and change over time? The answer is a special concept called state.
State is, quite simply, a component's memory. It's any piece of information that needs to change, usually because of something the user did. To give a component this memory, you use a special tool from React called the useState hook. And it's simple. It gives you the current value and a function to change that value later.
Here's what it looks like in code. We're telling React, hey, I want this component to remember a piece of data called number, and we're giving it an initial value of 0. In return, React gives us back two things, the current number and a function, setNumber, which is the only way we should ever update it.
Okay, now this is where things get really interesting and it trips a lot of people up. Let's say we have a button. When a user clicks it, our code calls that setNumber function 3 times in a row, trying to add 1 each time. What do you think happens?
The answer is 1. And the reason is, one of the most important concepts in React, state is a snapshot. In any single render, the value of number is fixed. It's frozen in time. So when this click handler runs, number is 0. All 3 of those setNumber calls see that number is 0, and all 3 tell React, hey, please set the state for the next render to 1.
So understanding how state works is one thing, but how you organize it? Man, that can be the difference between a clean, elegant application and a buggy, confusing mess. Thankfully, React gives us some excellent guiding principles for this.
The goal with all these principles is to get to a single source of truth. That just means any single piece of data lives in exactly one place. When you do that, when you group your state and you're ruthless about getting rid of redundancy, your components become dramatically simpler to think about.
And here is a perfect example of avoiding redundancy. On the left, in the bad column, we're storing full name in state. This is a trap. Now we have to remember to update it every single time first name or last name changes. The correct approach, on the right, is to just calculate it on the fly during the render. The rule is simple. If you can calculate it, don't store it in state.
This is a classic problem. It's great for one component, but what happens when multiple components need to share and coordinate state? If 2 child components need to be in sync, where does that shared state live?
Well, React solves this with a really elegant pattern called lifting state up.
And the process is pretty simple. You find the closest common parent of the components that need to be in sync. You then literally move the state up from the children into that parent. Now the parent owns the state, and it passes it down to the children as props, along with functions that let the children tell the parent when to update that state. The parent becomes the single source of truth.
So far, our components have been living entirely within this nice, clean React world. But what happens when they need to interact with the outside world? Things like browser APIs, third-party libraries, or network requests.
These interactions are called side effects, and they kind of break our pure function rule. So, React gives us a special, well-defined place to put them: effects. You can think of effects as an escape hatch that lets your components step outside of React to synchronize with some external system, but in a very controlled way. Effects are designed to run after rendering has already happened and changes are on the screen. So if your logic needs to run because a component was displayed or updated, and not because of a specific user click, it's a perfect candidate for an effect. Think about connecting to a chat server, fetching data from an API, that kind of thing.
So, why does all this matter? Because this mental model isn't just theory. When you embrace declarative components and well-structured state, you're not just writing code anymore. You're building systems that are predictable, easy to test, and honestly, a genuine pleasure to work on.
And that brings us to the one question at the heart of this entire philosophy. Is your UI a function of its current state? If you can build your components to confidently answer yes to that question, then you've absolutely mastered the art of thinking in React. Thanks for joining this explainer.